In this lesson, we'll start to talk about some of the basics of working with RealFlow's fluid particles. Okay, so really one of the things that RealFlow is obviously very well known for is its ability to simulate fluids. Now within RealFlow, we can do that through these basic fluid particle emitters. So what we can do is go up to this very top menu, and where we see these three little blue spheres, this is basically our emitter list. So we have things like circle, square, sphere, and so on. And essentially this just controls the basic starting shape of our emitter. So if I were to start with something like a circle, you can see we have just a very simple circular shape, and this is basically the shape of our particles that will be emitted out. Now when it comes to actually working with these particles, what we first need to do is essentially simulate these. So within RealFlow, we can simulate those by using this Simulate button. Now it's important to note that this Simulate button is fundamentally different than something like just our timeline playback. So if I were to come in and just simply play back my timeline, you can see nothing happens. So if I were to rewind and instead use Simulate, we can see our actual particles are now beginning to flow out of this little emitter. And you can see once again that they emit out in basically this same rounded shape as our emitter. Now you'll notice that once I simulate this through, that my timeline turns sort of this yellowish orange color. This is really signifying that these frames have now been simulated and essentially have been cached out. So now as long as this has been played through, I can now come in and scrub my timeline and essentially just play back all the cached information that has been saved out. Now, in one of the very first lessons of this course, I mentioned that it is going to be very, very important to make sure that you properly set up your RealFlow projects for any kind of a project or a scene that you're going to be starting. And here's why. If I were to actually jump into the actual project for this particular lesson, again, this is going to be lesson 04 start. If I were to open this up and take a look through some of my folders, for example, something like the particles folder, if I open this up, once I simulate through, what RealFlow is actually doing is it's actually writing out a new file for every single frame in my timeline. So when I come through and I'm scrubbing and playing through this cached information, it's playing back the data that's stored in these individual files. And again, we have one for every single frame. Now, if you don't properly set up your project, these files may not be saved out, or they may be saved out in a location that you are not sure where they're actually at. So again, this is why it's really, really important to just take a few seconds and make sure that you properly set up your project so you can make sure that all of this cached information gets stored in the proper place. Now, it's really important to remember that anytime we come in and make any changes to really any part of our simulation, that means we're going to have to restart or re-simulate our scene entirely from the beginning. So for example, if I were to take this emitter, with that selected, I'll switch to my rotate tool and just rotate this off to the side. Now in my case, I'll start my simulation right around frame 63, or really some point here in the middle. Now if I were to come in and re-simulate, RealFlow is going to ask us, are we sure that we want to rewrite the information from frame 79 on, which is the frame that I'm on? We'll go ahead and just click yes for the sake of demonstration and let that play through. Alright, let that reach the end. And now what you'll see is if I were to come back through my timeline, you can see that RealFlow up to this point is simulating our particles downward, but it's only at this point where I started re-simulating that we actually see this new rotation. So really, really important to keep in mind that if you are going to be making any changes whatsoever to your emitter, typically you're going to have to start all the way back at the beginning and re-simulate. Now, typically, if you're going to have to restart all the way at the very beginning, instead of just simply coming back and dragging all the way back to the beginning of your timeline, a little bit easier way is to just use this Reset button. So Reset will basically come in, clear out our timeline, essentially now just making RealFlow forget all of that cached information, and now we can re-simulate. And at any point, if we want, we can just click on the Simulate button to stop. If we find that maybe our simulation's not proceeding the way that we want it, just keep in mind that anything after this point will not be simulated, or cached out, I should say. Now, I want to share with you a couple of keyboard shortcuts that I think you're going to find very, very useful when it comes to actually working with your simulations. As opposed to using something like the Simulate and Reset buttons right over here, I really prefer to use the keyboard shortcut. So the keyboard shortcut to simulate is going to be the A key on your keyboard. So just simply press A, and you can see our simulation begins. If we want to actually reset, the keyboard shortcut for that is Control A. So Control A, reset, and then just hit A again to simulate. If I want to stop my simulation, just press A again, and you can see my simulation has now stopped. Now, we can actually have as many of these particle emitters as we want within our scene. So again, if I were to press Control A to reset my simulation, let's go ahead and maybe drop in another circle emitter, or maybe even just a square emitter, so that way we can actually tell these two apart. So I'll switch back to my Move tool, grab this, move it off to the side, switch to my Rotate tool, and maybe just rotate this up as well. Again, to resimulate, just press the A key on my keyboard, and you can see that really without any sort of settings or anything like that, that the particles that we set up will all automatically react and influence each other. Now, the actual behavior of these particles is controlled by several different settings. Things like density, internal and external pressure, viscosity, surface tension. Really, these are all meant to simulate roughly the behavior of water. So we have things like the overall density, which is really just kind of the weight of this fluid, how much it's going to weigh, how dense and how prone to compaction that's actually going to be. Also with this, we can start to set up things like fluids with different densities, like oil and water, things that normally wouldn't mix. We also have the internal and external pressure, which is essentially kind of the balance between a fluid's internal structure and the outward pressure of that versus the air pressure that would come in from an external source. Also viscosity, which controls the tendency of the fluid to actually become a little bit more stringy. So this would be something like the difference of water versus something with a higher viscosity, which would be an oil or a honey type substance. And then finally we have the surface tension, which is really an object's tendency to actually start to break off and form some of these different clumps. And again, these are all meant to roughly simulate the behavior of water at some of their default settings. However, really it just depends on the type of look that you're going for as far as what actual settings you're going to be using. Unfortunately, there really are no magic settings within RealFlow that will get you the proper result every single time. It really depends every time on the type of look that you're going for artistically and just what it is that you're trying to simulate. So, like I said, unfortunately, there's really just no magic value that's going to give you the best result every single time. Now, one thing that you do want to be aware of is the actual resolution. This is something that you'll probably find yourself adjusting almost for every single scene. The resolution is really controlling the number of particles that we have within each one of these emitters. So you can see, looking at this, that both of our emitters have roughly about 6,000 particles. Now, if we start to actually increase the resolution, that will increase the number of particles, which at the same time will also increase our simulation time, but also tends to give us a much more realistic result. So if I were to select both of these emitters at the same time, I can actually change the resolution of both of them. So if I were to set this from a resolution of 1, let's say up to something like 5, you can see that it's now set that. If you wind up with any kind of a warning message, that's perfectly normal. You can go ahead and ignore that. Really, it's just mentioning that we have this interpolation set to none. And again, I really kind of prefer to leave that set to none, at least for my initial settings. Now, again, once we adjust any of these attributes and parameters, it's going to be very, very important that we reset our simulation all the way from the beginning. So typically, coming in and starting to change some of these resolution options and internal pressure, things like that, mid-simulation can start to lead to some erratic behavior and sometimes even crashing. So good rule of thumb, anytime you change any of these attributes, I prefer to come in and just basically restart my simulation all over again. So again, Control A to reset, and A to simulate once again. You notice now that with my resolution increased, that we have a much, much higher number of particles, and we can actually see the particle count for each of our emitters up here in the upper corner. And we can also see that we start to get quite a bit more detail and overall just a much more realistic behavior. Now, within these different emitters, we also have a couple of additional options in here. All the way down at the bottom, if I were to select maybe just my circle emitter, we have things like our emitter's volume, speed, and randomization. So with a volume, again, if I were to reset this, essentially a volume just gives us some kind of a starting shape to begin with. So if I were to set my volume at 1, you can see it essentially just starts with a stack of particles kind of already lined up here. If I were to set this up to a volume of something like 2, or as I start to go higher, you can see it just starts to build up a little bit more of a column of particles. And these are just basically our starting particles. So if you're going to try to simulate something that's maybe coming out of a water hose or a water faucet, typically you'll probably want to leave this volume set to 0. Now the speed is something that's very, very important. You'll notice that whenever I started to increase my volume, by default it set my speed down to 0. With my speed down to 0, you can see that we really get no particles whatsoever from that particular emitter. Now as I start to increase my speed, maybe to something like 0.2, just to show the difference, you can see that my emitter is working, but it's just pumping out these particles in a much, much slower way. So we can gradually start to bump this up. The default value for our speed is 2, but if I were to set this up to maybe something like 1, you can see that this square emitter is obviously moving its particles out much, much faster than this circle emitter. So again, Control A to reset. We also have our horizontal and vertical randomizations. So essentially what we start to get, if I were to zoom in maybe just a little bit closer to this square emitter, if I were to simulate this out, it's a little bit difficult to see, but you can actually start to pick up on some of these very, very straight, very even, sort of a grid pattern with our particles. Now if we didn't want this to be a perfectly straight grid, we can now come in and start to adjust the horizontal and vertical randomization. So if I were to set that maybe something like 1 and 1, and again, Control A to reset, you can see now we get something that is going to be much more erratic. And again, just depending on the overall look that you're going for, this might just help to break up some of the patterns and things like that that you may typically start to see within your emitters. Now, finally, we have our volume. Now, this volume, or this ring ratio, isn't something that's found on every one of our emitters. So, for example, if I were to take this circle emitter, we have this ring ratio, and essentially what that'll try to do is simulate something that is going to be more like a hollow emitter. So, again, Control A to reset. If you look closely, you can now see that instead of just having a solid shape of particles here, now we have really more of this little donut type emitter. And again, we should be able to come in and just continue to resimulate. And again, with our higher resolution and slower speed, these might start to take a little bit longer. So let's come in and maybe go back to my circle emitter, and I'll take my speed back to its default value of 2. That way these two emitters meet up at pretty close to the same time. You'll notice that as our simulation progresses, again, you can see our timeline starting to turn more this orange color. Also, in this lower corner, we have this ST. This is our simulation time. This is essentially keeping track of how much total time we've spent on our simulation since the last time we reset. So as we start to simulate, again, this can be a really good way of, if you leave this running over lunch or if you leave it running overnight, you can see just how much time was spent getting all the way through your simulation. So once I'm done, I'll go ahead and just press the A key on my keyboard again to stop my simulation. So looking at these particles, you can see that the behavior of these is not quite right. Something is a little bit off if you look at this. So what we have is a situation where these particles are actually colliding and interacting with each other. The problem, though, right now is that we don't have anything like gravity to actually pull these particles back down. So what we'll do in our next lesson is actually look at how we can start to use some of these different features, things like gravity and wind, things like that, to control our particle behavior.